Happy day, everyone. This is Oreko Yalushegun, Physics Mathematics Fundamental on YouTube. Please kindly refer to my last video on the derivation of the transverse wave equation. It is from that derivation that you can be able to appreciate how to use this equation to solve some problems. So today we want to solve a problem involving transverse wave equation. So before we go into the exercise proper, please do not forget to share, like, subscribe, and click on notification buttons on my YouTube to be able to have more video. Thank you. Now today we are taking a simple exercise on transverse wave equation. Now the question says the equation of a traveling wave is given by y is equal to 4 sine 5t minus 0.03x, where y and x are measured in meters and t in seconds. The question says we should determine the following parameters: the amplitude of the wave, the frequency of the wave, the period of the wave, velocity of the wave, the wavelength of the wave. And then don't forget that in my last video I've been able to discuss about what amplitude of a wave is all about. The frequency, the period, the velocity of a wave is talking about the displacement of a wave with respect to time. Then the wavelength, I've said this is distance between two successive crests or trough of a wave. Now, how do we solve this equation? In my last video, I actually proved a formula that a wave equation is a function of displacement along the x-axis and the time t. So y is given as a sine 2 pi over lambda bracket x minus vt. And I've said in my last video that 2 pi over lambda is known as a wave number. So in case you are asked to find wave number, what you just need to do is to divide the 2 pi by the wavelength of a wave. And this particular wavelength can equally, this wave equation can equally be rewritten as y is equal to a sine 2 pi over lambda vt minus x. Now, if you look at these two equations, the one that looks alike, like the problem we are given, is the second equation. So I'm going to use this second equation of a wave to solve this problem. Now, if you look at the problem given here, the coefficient here after this sign is 1, but the coefficient we have here is 2 pi over lambda. So I will use this 2 pi over lambda to multiply what is inside bracket so that I can have a coefficient of 1 here. So in a nutshell, I'm going to have y is equal to a sine 2 pi over lambda vt minus 2 pi over lambda x. Now, if you look at this equation I have here, and if you compare it to the equation given here, we can see that a corresponds to this 4. Therefore, our solution, the first solution we are going to have here, is that the amplitude a of the wave is going to be 4 meter. Answer. So then if you compare this equation again with this equation, I'm going to start with this side of this equation and this side of this equation. So if I compare now, I can have my 0.03x to be equivalent to this particular 2 pi x over lambda here. So I write 2 pi x over lambda. So x cancel x on both sides. So I have 0.03 is equal to 2 pi over lambda. So this particular lambda is the wavelength we are looking for. When we cross multiply, I have my wavelength now to be 2 pi divided by 0.03. And then in the calculator, let me calculate. 2 pi divided by 0.03. So I have 209.44 meter. So I've calculated the wavelength. So this is the wavelength of the wave. Now the next thing I want to calculate now is the velocity of the wave. If you look at this place has velocity here. So I'm going to consider this side of this wave equation, which corresponds to this side of this wave equation, because they have, this one has t and this place also has t. So both of them correspond. So in a nutshell, I'm going to write this 5t to be correspond to 2 pi vt divided by lambda. So this t cancel on both sides of this equation. So when I cross multiply 5 with the wavelength lambda, I have 5 times lambda divided by 2 pi. That will give us the velocity of the wave. And 5 times the lambda that we have here the other time is 2. That is that I have here the other time. The lambda is 209.44 meter. So I will substitute it here, times 209.44, then divided by the wavelength. So using the calculator, let me see what we are going to have. 5 times wavelength divided by 2 pi. Yeah, so we are getting our velocity to be 166.64 meter per second. So this is the velocity of the wave. Then another thing we want to calculate is the frequency. We know that generally velocity of a wave is a frequency of the wave times the wavelength. Since we know that velocity is a displacement over time, for a full wavelength, displacement is for a full cycle of a wave, this particular horizontal displacement become lambda, and this time become the period t, and 1 over t give us a frequency. So that's how we got this one from the fundamental definition of a velocity. Now, so the velocity of this wave is going to be the frequency that we are looking for times the wavelength, and then the velocity that we just obtain now is 166.64 is equal to frequency times the wavelength that we got was 209.44. So dividing both sides by 209.44, the frequency now becomes 166.64 divided by 209.44. So the frequency now, placing our calculator, 166.64 to 9.44. So we are having approximately 0.8 hertz. So 0.8 hertz is the frequency. To obtain the period t, that's the time taken to complete a full cycle. Period t is one inverse of frequency, which is 1 divided by 0.8. Pressing calculator, 1 divided by 0.8. So we are getting 1.25 second. So that is a simple question under the wave equation. Please do not forget to like, share, subscribe, and re-forward my my link to other contacts. Once again, this is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Thank you for your time. Have a nice day.